Hi everyone. So lesson 5.1 is about finding the area between curves. So in one of the videos that I watched, they gave you a formula for that. And that formula was the integral from a to b of f of x minus g of x dx. Okay, now when you're doing this, it's really important to know which curve is above the other curve. So sometimes they will tell you that in the example, and sometimes you have to graph to figure it out. Another thing that's really more challenging about these questions is that sometimes they don't give you the A and the B. Okay, and one way that we can find those out is simply by figuring out where the two graphs cross. So if we graph it, and for this I really like using a online graphing calculator. So if we graph it, we can find a value where it crosses, and this is going to be the first place where it crosses, and this is going to be the second place where it crosses. So sometimes they will tell you A and B, and other times you have to figure them out for yourself. So let's take a look at our example 1. Okay, it says, find the area of the region bounded above by y equals x squared plus 1, bounded below by y equals x, and bounded on the sides by x equals 0 and x equals 1. Okay, so I'm going to set up my integral. So my integral has to have a lower bound of 0, an upper bound of 1. Okay, and then I'm going to take the graph that is above x squared plus 1 and put it first. Then I'm going to subtract the graph that was below x. Okay, and then I write my dx at the end. Now, step 1 is to just simplify this. So I'm going to simplify this as much as possible, which really there's not much I can do, but I can write it in the normal form for a quadratic. So I have x squared minus x plus 1 dx. Now this I can take the integral of. Sometimes you do need to simplify this a little bit more. So the integral, I'm going to use my power rule. So go up by 1 on the power of 2. So it's x cubed. And then divide by that power. Okay, for this x, I'm going to go up by 1 on its power. So squared. And then divide by that power. And last, this 1 is a constant, so I'm just going to write 1x, or just plain old x. Now this I have to evaluate from 0 to 1. So I really like it when they put 0 here, because generally the result when you evaluate for 0 is just going to be 0. Now if I put in a 1, this term is going to be 1/3. This term is going to be minus 1/2. And this term is going to be 1. Okay? Now I just need to subtract out the value from 0. So if I put 0 in, I'm just going to get 0. Okay, so the last step that I need to do is simply get common denominators and combine my terms. So this is going to be 2/6. This is going to be 3/6. And this is going to be 6/6. Okay, so 2/6 minus 3/6 is negative 1/6, and negative 1/6 plus 6/6 is 5/6. So that is the area in between our two curves. Okay, so we have another example. Okay, this time it's going to take a step harder. They're not going to give us our upper and lower bounds. So let's take a look. Okay, so they want us to find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. So step 1 is going to be to graph it. Now I did graph it on an online graphing calculator, and I'll show you the graph that I got. Okay, so it's this top graph here. Now what I've done is I'm going to highlight in green the parabola that is above. Okay, and this is going to be the 2x minus x squared parabola. Okay, and then I'm going to highlight in blue the graph that's below. Okay, that's this one here. Okay, and this is the x squared parabola. Now, I like to go on Desmos for this. So Desmos.com, really good use for this because all you have to do is you graph both of them. And then if you click on this point right here, it will tell you exactly what ordered pair that is. So when I clicked on that, I got the value that is 0, 0. Okay, and then I clicked on this other intersection point, and I found out that that was the point 1, 1. So what we want is we want the integral of 2x minus x squared evaluated from x equals 0 to x equals 1. Okay, so I took those x values from the point, not the y values. So let me show you that work. Okay, so it's the integral from 0 to 1 of 2x minus x squared. Now, a lot of times we'll put these in parentheses just to make it a little less confusing, especially when the function that you're subtracting has to be like a polynomial here. It definitely helps to have those parentheses. In this case, it's not really necessary because this is just a single term. But it did help me to identify which one is f of x, the top function, and which one is g of x, the bottom function. Okay, so now I'm just going to simplify this, which is the integral from 0 to 1 of 2x minus 2x squared dx. Okay, now I'll use my power rule to fix my x's. So this x becomes an x squared, and this 2 gets divided by 2. Okay, and 2 divided by 2 is just 1. So I'm just going to turn this into a 1. Now, this power goes up by 1, so I have x cubed, and this 2 gets divided by 3. Okay, and this is evaluated from 0 to 1. Okay, so next, what I'm going to do is evaluate. If I put in a 1, I get 1 squared minus 2/3 times 1, or just 2/3. And then I'm going to subtract. Now, if I put in a 0, I get 0 minus 0, which is just 0. Now, again, I'm going to get common denominators. This is 3/3 minus 2/3. And the minus 0 doesn't really matter, so I'm just going to write 3/3 minus 2/3. So this is 1/3. Okay, and that's our answer for that. So those are examples 1 and 2 from our lesson. There will be another video with the next few examples.